Today we're learning how to translate the sine and cosine graph. And this is translating the graphs that we've been working on over the past two lessons. In previous functions that we've graphed, we've learned how to shift left, right, up, and down. When we're dealing with a trig function, we call your left or right shift a phase shift. So if you're shifting your graph left to right, you would start with your original function, and you would graph this by moving it to the left or to the right. It just shifts on the graph, specifically called a phase shift. If you're working with a vertical shift, that means you are shifting your original graph up or down. Translating trig functions is a bit more complex than previous graphs that we've learned about because there's more variables that could have certain values. So now we're looking at an A value, B value, C value, and D value. The thing is it's not quite as easy as just identifying each value. There are different formulas you have to fill in to determine certain parts. So let's start with the amplitude, which is something we've already learned. We've learned that the amplitude is always the absolute value of A. We have also learned about the period, and the period is a formula. It's not as easy as just saying it's the B value. It's specifically 2 pi over B. So make sure you use that whole formula to find the period. The two new shifts are called your phase shift and your vertical shift. So your phase shift is determined by your C and B value. You have to look at both of those terms. The phase shift is going to be C divided by B. And that tells you that you're shifting your graph left or right. The vertical shift is as easy as it's always been, as easy as it has always been. The vertical shift is just your value of D, and that's telling you to go up or down. So the two big ones that take up a little bit more time are your period and your phase shift when you're graphing these functions. Both of those involve a formula. They are not as simple as just a single value. So a couple of notes before we start graphing. One of them I actually typed for you. It says when the trig function is shifted up or down, the line y equals k is the new midline. So the graph midline shifts up or down with the graph, and that midline is where the graph oscillates from. So it means it's where its central location is as far as the wave on the graph. Also, when you're graphing a phase shift, so when you are graphing left or right, you need to make sure you have the correct increments marked on the graph. And marking the correct increments takes a little bit of practice. You definitely have to be aware of fractions and how to increase or decrease by a certain value. Anyways, before we get right into the graphing, let's take a moment and describe the phase shift for each one of these functions. So recall that your phase shift is C over B. Also recall that standard form has a subtraction sign. So if you don't see that subtraction sign in between your B, X, and your C value, then you can assume that value is negative. So for number one, we have cosine of theta minus pi over 3. And your phase shift is always found by C over B. I'm going to label the B value is always B theta minus C. So in this case, our C value is pi over 3, and our B value is just 1. So this one makes it a little bit easier. That tells us that our phase shift is going to be pi over 3. That's your final answer. That tells us that you're shifting the graph pi over 3 units. If your increments don't go up by pi over 3, you need to rework those increments, meaning you need to find different increments for your graph and you need to make it clearly legible that it's increasing by pi over 3, or it's shifting by pi over 3. If I look at this graph that's done out for me, if we have our parent graph with a point right here, we would have to shift this graph pi over 3 units to get it to its correct location. Also, because this is a positive value, you would be shifting to the right. If it was negative, you would shift to the left. I think everyone knows that at this point. For number 2, we have y is equal to 2 times sine of 2 theta plus pi over 2. In order to determine the phase shift, you have b theta, and then technically it's minus c. So if we don't see a subtraction sign right here, then our term is negative. So in this case of finding the phase shift, we have c over b, which according to our problem, our b value is 2, our c value is negative pi over 2. So negative pi over 2 divided by 2. And then when you do this, you need to make sure that you multiply by the reciprocal. So we have negative pi over 2. And instead of dividing by 2, we're going to multiply by 1/2. And this gives us the phase shift of negative pi over 4. This here is your phase shift. And because it's negative, we will be shifting to the left. As we move into graphing, I typed out the directions for you, so I'll briefly read through them. The first step when you are graphing is determine the amplitude and the period, which we have already done, so we've been practicing that on the last 2 lessons. Step 2 is to determine the vertical shift and the midline. So you're going to determine if you're moving up or down. And that's going to be your d value, so it's that last constant value off to the end of the problem by itself. This value here. And step 3 is to determine the phase shift, which is what we were just working on, and then you need to translate the graph accordingly. So I'm going to take a moment and actually let me copy this so we can just take or save a second. All right, so here's our function. Whether it's sine or cosine, it doesn't matter. We have the same values. So if I was to rewrite this directly above my first graphing problem, which is 2 times cosine of theta minus 1, I would write the original function as a times cosine. In parentheses, I would have b times theta minus c, and then plus d. So to start with, I'm going to determine my amplitude by the absolute value of a. And in this case, the absolute value of a would be the absolute value of 2, and that tells us the amplitude is just 2. After I find the amplitude, I'm going to find the period, which is determined by 2 pi over b. And in this example, we have 2 pi divided by, our b value is 1, so it's just 2 pi. And then lastly, we're going to determine the vertical shift for this problem. So we clearly do not have a phase shift. We don't have anything in parentheses here. All we have is our d value. So that's telling us that we are going to shift this graph down 1 unit. The d value is equal to -1, which is telling us to go down 1. All right, so if I scroll out to the directions, It says determine the amplitude and the period of the function. Then step 2 is to determine the vertical shift and shift the graph. So I'm going to start by marking off my amplitude at 2 and at -2. I determined that over here. I also know that the period is 2 pi. We've graphed 2 pi so many times as a period. Hopefully everyone is aware that your graph goes between 0 and 2 pi, but also if you were to mark off your increments, which you do have to, it goes up by halves. So we have pi over 2, pi, 3 pi over 2, and then of course the end of this cycle, which is 2 pi. I'm going to sketch this graph. It's a cosine function, so it starts at 2. I'm going to sketch it with a dashed line because it is not my final answer. We do have to translate this graph down. So according to the directions above, I just graphed step 1, which is my amplitude and my period. Step 2 is to graph my vertical shift. So with the vertical shift, everything shifts down 1 unit. You are going to have to mark some more tick marks on your y-axis for problems like this. So our graph currently has an amplitude of 2. I just need to make sure I indicate where my increments or my other increments are going to be. That way when I shift it down 1, I have all points clearly marked. I'm going to take every value and I'm going to shift it down 1 unit. So every value from the said parent function is going to move down 1 unit. And this pink graph will be my final answer. The only thing left that I want to show is that the midline, which was originally here, the midline also shifts down 1 unit. So now the midline is here at -1. The amplitude does not change. The amplitude is still 2 points above that midline. And it's still 2 points below the midline. So when you move the midline, it is also keeping the amplitude consistent throughout the problem. And this here is my final answer, this graph. Now for the next example, we are going to be looking at a phase shift and not a shift up or down. Sorry, I just realized that on my note sheet, your note sheet is correct, but mine has 2 functions here. I'm going to cross that one off. We're graphing this function, which is what is on your paper. So just like I did above, I'm going to write the standard form function, which is a times sine, and in parentheses we have b times theta minus c, and then minus d. So you can clearly see that we have a c value, we do not have any d value, so we're going to be shifting this left or right. The amplitude is the absolute value of a. In this case, it's the absolute value of 1, which is 1. The period is 2 pi divided by the b value, and here we just have a single value of theta, so that means the b value is 1, and the period is 2 pi. And now our phase shift is determined by c over b. This is new. This is the first one we're graphing with a c over b value. The subtraction sign is standard form, so our c value is actually positive pi, and our b value is 1, so our phase shift is pi. That means we are shifting the graph right pi units. I know that sounds different because it's not saying to the right 1 or 2 units, it's shifting to the right pi units, but just make sure you look at the increments on your graph and it shouldn't be that challenging. Step 1 in the direction says to graph the amplitude and the period. So we're going to mark +1 and -1 on the y-axis. The period goes between 0 and 2 pi. So same thing as above, our increments are pi over 2, pi, 3 pi over 2, and then 2 pi. This is the sine function, so it starts at 0. I'm graphing my parent function as a dashed line. And after I have my parent function, I'm going to recognize that I need to shift this graph to the right pi units. That means I am taking every point and I am shifting it pi units to the right, which ends up being 2 increments on my graph. So that point that I just circled is going to get plotted, replotted here at pi. That means I'm going 1, 2 units. This point here is going to shift over 2 units as well. If every point is shifting over 2 units, we have a new point here. I am going to have to extend, oh, I just noticed I forgot to write 3 pi over 2. I am going to have to extend my increments. So if I have increments going up by halves, I have 2 pi, which next comes 5 pi over 2, and then next is 3 pi. After 3 pi is 7 over 2. You absolutely have to mark these. I have to be able to see what your final points are and where they are. Okay, so back to the graph. We just translated 3 points. We translated this one, and this one. Next, we're translating this point over 2 units. And lastly, we would translate this point, which obviously you can't see the original one, but it is there. That's shifting over 2 units as well. And I'm saying 2 units because it's 2 increments, but it technically is pi units as a shift. All right, our final answer is this pink graph here. The midline didn't change, the graph didn't shift up or down, it just shifted from our 0 to our pi, and that is where the first cycle started. So it shifted to the right pi units. Okay, number 2 for an example of a phase shift is 2 times sine of pi over 2 times x. This is the first one I have typed out with an x. That's the same thing as theta. It's just a placeholder for the angle measure, so no difference there. So pi over 2 times x plus pi over 4. The amplitude is going to be the absolute value of a, which is 2. The period is 2 pi over b, and our b value is going to be pi over 2. So we have 2 pi divided by pi over 2. Simplify this to 2 pi over 1 times the reciprocal of the second fraction, which is 2 over pi. Pi is going to cancel, and we're left with 4. So now, for the first time out of all the graphs that we've graphed, our period is between 0 and 4, which is a whole number, so it does make it quite a bit easier when you are shifting left or right. And lastly, the phase shift is c over b. Because subtraction is the standard, this is actually a negative c value, so we have negative pi over 4 for the c value, divided by our b value, which is pi over 2. I'm going to multiply by the reciprocal, so I have negative pi over 4 times 2 over pi. The pi values are eliminated. 2 goes into itself once, 2 goes into 4 twice, so our phase shift is negative 1/2. This tells us that we are shifting left 1/2. All right, to start with, graph my amplitude. Up 2, down to negative 2. I'm going to mark out my period, which is between 0 and 4. That means my increments are just units of 1. 1, 2, 3, and then 4. I'm going to graph my original or my parent function. It is a sine function, so it starts at 0. Graph this with a dashed line. We are shifting this graph half a unit to the left. So I do need to add in some increments of halves just so I can clearly see where I am shifting this graph. So I just marked negative 1/2, and on the positive side, I'm going to mark 1/2, 1, 1.5, which is 3/2, 2, 2.5, which is 5/2, no pi, just 5/2, 3, 3.5 is 7/2, and that should be enough for us to shift the graph half a unit or 1/2 to the left. I'm going to take every point, I'm going to shift it half a unit to the left. And this pink line is my final graph. So that was a nice one to look at as far as the phase shift because we didn't have pi in our fractions. Our fractions were all whole numbers, and there you could clearly see how we are adding in our values to make sure we can see where we're graphing on the coordinate plane. You're going to have to do that for other problems as well, even when it's not going to be such an easy number to shift. So the increments might get rather difficult, but you need to make sure you always add in whatever you need to or write in whatever you need to show where your points are. And for the last example, we'll be graphing a cosine function that has all parts. So this one has a vertical shift and a phase shift. If we recall what the general form is, we have a times cosine of b times theta minus c plus our d value. So to quickly go through and fill in our key parts, we know that the amplitude is the absolute value of a. In this case, it's the absolute value of 1, which is 1. The period is 2 pi over b, and in this example, it's 2 pi over 1 or 2 pi. The vertical shift is going to be your up or down shift. It's the value of d. So here we have a d value of -2. So that's telling us we're going to be shifting down 2. If we shift down 2 units, that means the midline also shifts down 2 units. So the midline starts at 0, and then shifting down 2 units would create a midline at y equals -2. You could fill the midline in after you finish graphing if you don't understand what I just talked about. But remember that every time you start a function, it starts at 0 and it shifts up or down. So essentially, your vertical shift and your midline will be at the same location or be the same number. Okay, the phase shift is c over b. So here we have a c value of pi and a b value of 1, which is equal to pi. That tells us that we are shifting pi units. Oops, I actually forgot the negative sign. We're shifting to the left on this one. This should be negative pi. So if the phase shift is negative pi, that means we are shifting left pi units. Okay, so I'm going to go ahead and get started by graphing my amplitude and period. That way I can get my parent function. The amplitude is at 1 and -1. And if my period is 2 pi, to evenly split this between 0 and 2 pi, I'm going to have increments of 1/2. So I have pi over 2, pi, 3 pi over 2, and then 2 pi. When I graph this function, it's a cosine function. It is a positive a value, so I'm going to start at 1. I'm going to graph my cycle. I'm going to indicate this is my parent function by graphing a dashed line. And then once I have this graph graphed, or once I have the parent graph graphed, I'm going to shift up or down. Here we're shifting down 2 units. So I am going to have to add a couple increments to my y-axis just to make sure I have enough room to shift this down full 2 units. But once I have that, I'm just going to take every point and shift it down 2 units. With that, the midline also shifts down 2 units. So whereas the midline was originally at 0, right here, we are now going to shift this down to -2. And lastly is our phase shift, and our phase shift is telling us that we're shifting to the left pi units. So we're going to have to move this graph in this direction, which means I'm going to have to mark some increments on the left side of my graph. So I'm just going to take a moment. I'm going to mark off the fact that we're going to have negative pi over 2. After that comes negative pi. After that comes negative 3 pi over 2. And then negative 2 pi. Remember, it's just a reflection of this side. If every point is shifting pi units to the left, recall that pi units would be 2 units away from 0. So to start with this point, I'm going to shift this point over to negative pi. And this purple line is my final graph. Okay, if needed with other graphs, you might have to add in some increments. So you might have to change what your graph is shifting up or down by. For example, let's say this graph is shifting pi over 4 units to the right. That's telling us that we're going to have to add in some values. So I'm going to have to add in, pi over 4. Then would be pi over 2. Then we'd have 3 pi over 4. Then we'd have pi. Then you'd have 1 1/4, which 1 1/4 is 5 pi over 4. So you might have to change some increments to make sure that your graph fits. In this case, you did not have to. You just might see that on some other graphs. Okay, that's it for examples today. I can't go live, but if anyone has any questions, please feel free to email me. Or if you'd like to see more examples done out, you can email me for that as well. Have a nice day.